0.25 mole oxygen is equal to 0.25 multiplied by molar mass of oxygen.
Yes.
That is 32. So we will get 8 gram of oxygen will be produced final answer.
Yes, exactly. But sir,
Yeah.
for converting it into mass, like, does it depending on the question or is it always the same? Converting mole into mass, like, does it
Yeah.
depend on the question or is it always like the same?
Yeah. This will be always at the same. So understand, quantitative means technically what? Suppose it is give us in gram, then still we have to convert it into mole. Why?
Okay.
Because there is no comparison regarding mole. Every time when reactant will change, its molecular mass will change. So only we have to compare with the number of moles, and number of moles always we know. Why? Because balance equation will be given, obviously.
Yes, yes. But
Then,
like, why did you
yeah.
times it by 32?
Hmm?
Why did you times it by 32?
Why I am telling this?
Because 8, 16 times 2 basically, because of the oxygen.
Oxygen. Okay. So molecular mass, oxygen is 16. One atom of
Times 2?
oxygen is 16. So O2 means 2 into 16, that is 32.
That's it. Okay.
Okay. So whenever we are finding a molecular mass, how to find the molecular mass of atom? Count the total mass of atoms.
Can you give me an example question? I'll do it.
Yeah. So to find molecular mass, so it is sum of atomic mass of all atoms. Sum of total atomic mass, we should say. For
Yes.
example, suppose I am saying methane. So how much its molecular mass will be?
Carbon 4, and how much is carbon? 12?
Carbon 12 and 4. So it would be
10
16.
plus 4, 16.
Right. So CO2, like, so again 12
So the
plus
12 times 36,
uh,
32,
and 2 into 16.
which is 32, 11, 16, yeah, 32, plus 12, 44.
Very good. Okay. And suppose I am giving you Al2O3. Atomic mass of aluminium is 27 and oxygen
So
is
20,
3. Yeah.
okay, 1 second, 27 times 3,
Try
1,
this by yourself. Very good.
81, 18. Sir, is it a 129?
129. You are saying 129. Let me cross check.
Yeah,
So
yes,
27 into 2
81.
plus 3 into 16.
Oh, I did 27 into 3. I'm sorry.
There
Okay,
aluminium is 2.
1 second. So it's gonna be 101, 102, 102. My bad.
Yes, 102.
102. Yes, I'm sorry, I did aluminium times 3.
Yeah. Sodium carbonate. Atomic
Okay.
mass of sodium is 23.
Sodium is 20. Okay. Thanks, sir. Times 2. Carbon is 16. Plus 16. And oxygen is. Carbon is 12 or 16? It's 12, right?
Yeah, 12.
Okay. That's 12. Times 2. 16 times 2. Is it gonna be 1 second. 5, 8, 4, 3, 5, 8, plus 5, 8. It's going to be 106?
106, correct. Very good. So now you are able to find the molecular
MR.
mass. Right, very good. One more last example we should
Yes.
take. Ammonium sulfate.
And what's this?
So
What does it have?
nitrogen is 14, hydrogen is always 1,
Yes.
sulfur is 32, and oxygen is 60.
Okay, 1 second. Two. Is the 132?
132, correct.
Fish.
Very good. So for every compound, you can calculate its molecular mass if providing the atomic masses, correct?
Correct. So how do you calculate the AR?
AR?
Yes, the AR. I forgot.
Atomic mass, right?
Yes, AR. Yes.
No, there is no method for calculating AR. It is only provided, always given.
So we don't calculate it.
It will be always given.
Okay.
So, but actually, many of atomic masses I am directly remember. That's why I am instantly saying that nitrogen 14 and oxygen 16 and all.
Oh, nice.
I know the atomic masses. I think up to 30 atomic numbers I am good for the
You
atomic
said them in
masses.
school?
Yeah.
Yeah.
So it enhances your speed for calculating. Otherwise, you have to depend on the given data and all that. That's
Yes.
why. Okay, so understood that thing. Now
Yes, very easy.
very easy, right? Now again,
Yeah.
come again on the our topic that quantitative chemistry. You want some more question, right? How much the gram will be produced? So suppose I am taking calcium carbonate, right? And on heating, it is providing us calcium oxide and CO2.
Okay.
Okay. And now it is given that initially I have 150 gram of calcium carbonate. So how much calcium oxide will be produced?
So we find the MR, step 1.
Now atomic mass of calcium is 40. Carbon 12, oxygen
12,
16.
16. Okay, 1 second.
This data you will be needed.
1,
How much gram of calcium oxide will produce? Starting from 150 gram of calcium carbonate.
Is the 100? The MR is 100.
Yeah, 1:1 ratio is there, right? Very easy.
Yes, so you just cross
And
one.
okay, molecular mass is 100 for calcium carbonate, right?
Yes, and then you just divide it.
Of calcium carbonate is 100 and MR for calcium oxide is how much?
Calcium oxide is Ca 40 plus 16 basically is going to be 5, 6.
5, 6, correct. Okay.
5, 6 divided by 100. Do we do 5, 6 divided by 100?
No, you will need it later. First try this, how many moles we are taking of calcium carbonate?
2.
No, 1.5.
Why do we get 1.5?
How many moles of calcium carbonate Mass upon molecular mass.
150, yes.
So it is 1.5.
Yes, 1.5, 100%,
And
yeah.
the ratio is saying what? Ratio is saying 1:1. So if I am saying that 1 mole of calcium carbonate is equal to 1 mole of calcium oxide.
Yes.
So for 1.5 mole, I will write
1 divided by 1
1 divided by 1 multiplied by
times
1.5.
1.5,
Correct. That means
which is going to be 3 over 2, 1.5.
1.5 mole. So for 1.5 mole of calcium oxide, now I can count the mass. Mass of calcium oxide will be 1.5 into MR.
And
That is
M is
56.
going to be 156, yes. 1.5 times 56 is going to be 1.5. 1.5 times 56 is going to be 84.
Yeah, 84.
Can you give me one more question so I can do it?
Yeah, I will give you. But also, first understand the concept. At the end, I
Yes.
will provide you some questions as well.
No
One more
worries.
thing I want to add in this thing.
Yes.
Sometimes the reverse question can be asked. Reverse question means what? Suppose the same thing is there, calcium oxide and CO2. Okay. And
Okay.
it is saying that it is producing, suppose 132 gram of CO2 produced.
Okay.
Then what was the mass of this calcium carbonate initially taken?
So do we repeat the steps but like different from reverse?
Yeah, just we have to compare. This time we will find the moles of CO2 and compare it with the moles of calcium carbonate. And
Okay,
once
so the
we
mass.
got the moles of calcium carbonate, then again multiplied by MR and we will get the mass of calcium carbonate.
So this. Okay. Was it not
Initial.
100?
So first you will find the
Moles.
moles of CO2. So it is given mass
Moles.
divided by molecular mass. What is MR for CO2?
And what for CO2 carbon is 16 plus 12, 24. It's going to be 16 plus 24, which is going to be 40.
Carbon is 12, oxygen is 16.
Oxygen 16, my bad. 16 times 2. So it's going to be 44.
Correct.
So it's going to be 3.
Yes, 3. So
And
now
then
what we will then, yes, comparison 1:1.
1, 1. So the ratio is always 1, 1.
No, it is depending on the given equation.
How do we know how to calculate the ratio?
Equation is given. Let
Like,
understood. Let like for water, what is the balance equation is written?
yeah, it's 2H2O
It is 2, 2,
equals
1,
2.
right? So for this it will be 2, 2 or 2, 1 depending on question. If it is asking for oxygen, we will take 2 and 1. And if it is asking for
Okay.
water, right?
Yes, it's okay.
So,
I
but
understand.
yeah. So we will do that different question as well.
Because there's no number in the front of it, right? That's what it's
Right.
1, 1.
So here directly we can say that 3 moles of CO2 will be equal to 3 mole of calcium carbonate
Correct.
because 1:1 ratio is there, correct?
Yes, then we make 132 grams of CO2 equal 3 divided by 3 times 1, 3 times 3, right?
Can we say like this? 3 moles CO2 will be produced from 3 moles of calcium carbonate.
Yes.
So once we get the moles of calcium carbonate, mass of calcium carbonate is 3 into 100 because molecular mass of calcium carbonate is 100.
Yes.
So just multiply it by 100, 300 gram. That is our final answer.
But I thought we divide 3 by 3.
Yeah, 3 by 3 and no. Why 3 by 3 you are dividing? 1 by 1 multiplied by 3 should be there. See the step 3. Suppose I am saying 1 mole of calcium carbonate producing 1 mole of calcium carbonate.
Yes.
So similarly, it is 1:1. So 1 by 1 multiplied by 3 should be there, not 3 by 3.
Because the ratio.
Yes, 1 by 1 multiplied by 3. Understand what the chemical reaction want to say you, that this CO2 comes, 1 mole of CO2 comes from 1 mole of calcium carbonate. Okay, I got where you are confusing. Let it be clear. Just we can write like this, that according to equation, right?
Yes.
According to equation, we will say 1 mole CO2 produced from 1 mole calcium carbonate. So 3 mole of CO2 produced from, so now what you will do?
1 divided by 1 times 3.
1 times 3. Yeah, simple. So there is 3 mole of calcium carbonate.
Yes. Yes, that's
and then mass of calcium. Yeah. And then 3 multiplied by.
Okay, very easy. Yeah.
Now suppose this balance equation is given, N2 plus thrice H2 converting into plus NS. And I am taking from 8 gram hydrogen how many grams of ammonia can be produced?
Okay. Is the ratio 3 to 2?
What?
The ratio is 3 to 2?
Yes, 3 is to 2 this time.
Okay. So the first step we do is finding the MR of N3H. Now, how much is N, sir?
First you have to find the mole of hydrogen, right?
Yes, hydrogen is 1. The mole of hydrogen is 2.
Molecular mass, yes, MR is 2.
Yes. So divide 2 by 8, which gives you 1 over 4. 0.25.
8 by 2, that is 4.
8 by 2.
4 moles?
Yeah. Yes. Okay. Next step we do is we find we put the ratio of 3H2O, which is going to be 3 moles of H2 produces 2 moles of NH3, 2 moles of N23, and then under the 3 moles we write So
we have
8
4
grams,
moles. So
4
4
moles
mole is
exactly.
2. Right.
And then we find 2 divided by, no, 2 divided by 3. It's not 3 divided by 2? No, 2 divided by 3
Multiplied
times
by
4.
4. Right.
Times 4, which is going to be 8 over 3
8 over 3. Okay. 8 over
moles.
3 moles of NH3.
And now when we want to find the M, the one for the grams of it, we need to find the M mole of NH3. What's the N? What's N?
14. 1 4.
Okay, 14 times 3. 14 times 3 is going to be 42. 17, I am wrong, it's plus it.
Yeah.
17, yes. 8 over 3 times 17 is going to be equal to 136 over 3. It's going to be a 45.3 grams.
One 36 over 3, correct. 45.33. Very good. Now you understand completely, I think so.
Yes, it's a very nice topic. I enjoy it.
Yeah, it's very interesting topic.
So, because I want to go into.
So now I am writing some questions. Yeah,
Yes.
you want to say something?
Yes, I want to say I need to get better in chemistry because I want to pick it for A-level.
Couldn't understand. Chemistry is?
No, I want to become better at it because I need to take it. I want to take it for A-level for the last 2 years of my school.
Okay.
It's a subject, but like very hard. That's why.
Now it will be easy for you.
Yes, I hope so.
Okay. Yeah. Okay, so I am writing some questions for homework as well.
Okay. And sir, can you teach me how to balance out equations? I always get confused.
Yeah, I will give the equation.
Don't know how to balance them out. You get questions and
Okay,
balance
yes.
out.
We will do that thing as well.
Okay.
So I am taking 6 gram of oxygen. How much magnesium oxide will be produced? Okay. So AR for oxygen is 60. AR for magnesium is 20. So how much gram magnesium oxide will produce? You will do that.
Okay, homework.
Homework, yes. 2 questions I am giving you for homework. Oxygen. I am taking 51 kilogram aluminium oxide and asking the mass of aluminium in kilogram as well. AR for aluminium is 27. AR oxygen you already know 16. Okay?
Yes.
So this will be your homework.
Okay.
Okay. Now the balancing of equation, how we will do, let's understand. Balancing of equation. So balancing of equation is an entirely different thing, but we can do either if providing us masses, or either the providing reactant and products.
So So
Suppose
masses, yeah.
uh, that will be different part. That will be numerical. So we will discuss this later. First understand, like suppose it is given when H2O2, H2O is producing hydrogen and oxygen, suppose. So this is
Okay.
unbalanced, correct?
Yes.
Now I want to balance it. So first of all, I will check the number of atoms. Like here, two hydrogen atoms are there. Two hydrogen atoms are there. So that
But
means
one
hydrogen atoms
oxygen,
are balanced.
the oxygen.
So now I come to the oxygen. Here oxygen have only one atom, while in the product side there are two atoms. So what I will do? I
Okay.
will multiply it by 2.
Now
Now
it's
the
all balanced.
oxygen atoms are balanced, but in the meanwhile now there will be 4 hydrogen atoms. So hydrogen atom become unbalanced. Now what I will do? I will do balance these 2 hydrogen. So now the
Uh,
overall 4 hydrogen atom here, 2 oxygen atoms here,
two
everything is
oxygen.
balanced now.
Can you
Okay.
not just remove the oxygen, the two from the oxygen from the product side? Is it not possible like that?
So every time we have to write the stoichiometry coefficient like this, and then compare the number of total atoms.
No, like I mean for to balance it out, cannot be H2O equal to H2 plus O,
No,
but it'll be the same. Ah, yeah,
no, yeah, yeah. You cannot write O because the product is oxygen gas. Free oxygen atom is not available,
yeah.
right? So, but also you will be provided with what? Provided molecules, or if there
Yes.
is an atomic level, then there most of the time it will be only for metal. Like again, if I am writing iron and oxygen, and it is making iron oxide, suppose Fe.
Okay.
So how would you balance that?
Okay, Fe and Fe are balanced. We
Yeah,
need to balance out the oxygen. So you do a put a two under the oxygen,
yeah.
a
So
two in
I
front of
should
the Fe.
multiply two. Yeah,
Exactly.
but
And now there's two Fe, so you need to do put a two in front of the Fe too. That's
correct.
it.
Yes, yeah. That's it. Now aluminium plus oxygen producing aluminium oxide. This one.
Okay. Aluminium is two on the other side, one there. Oxygen is three there, two there. So for balance out aluminium first, you put two next to the AI on the yes. You put two there. And then now it's two. And to balance out the oxygen, we need to put two, three, two. So we need to put a number. Oh, okay. We need to do the oxygen first. So
Yeah.
we need to rub out the two. We rub it out, and we put that two in front of the AI2O3.
Yes, so trying to do in the even number, like I mean twice the
Yeah.
aluminum, so the 6 atoms are there. Now thrice of the O2, 6 atoms.
And then
So
the other one you
oxygen
put
is,
four.
so now aluminum become 4 automatically.
Four.
Very good.
Yes.
Right. So this is the way how we will balance the equation.
Okay.
N2 and H2 producing an H3.
Okay. The H is 3 and the H is 2. The N is 2, the N is 2. So to balance out the 3, we put that 2 in front of the NH3. Yes. And then nitrogen becomes 2, so nitrogen is balanced. And we put that 3 in front of the H2, and then it's balanced.
Correct. So what we understand, whenever this situation like O2 and O3, we are cross multiplying it 2 and 3, right? Similarly,
Yes.
hydrogen 2 and 3, we are multiplying right 2 and 3. Simple. So that
Yes,
it
very
could be
simple.
balanced. And then cross check the remaining atoms, how to balance.
Yes.
Clear?
Yes.
So, balance. What is the sound for this?
Sorry. I think it's my laptop.
Oh, I think it's
Is
notification
it
sound
on?
on your phone. Okay, okay, no worries. So balance these equations. One
Sure.
is yes,
Hello?
yes,
Yeah. Do you hear me now? Yes, yes. Okay. Now it's
yeah,
enough.
okay. So for homework, I am giving you balance the
No worries.
equations.
No worries.
This H2O2 converting into H2O and O2, and another equation
Answer?
carbon monoxide plus O2 converting into CO2. So as you know that when the moles are given, masses are given, what we were doing? We are finding their moles and comparing according to the balance equation, right?
Yes. Right.
Now, if data provided us for an equation, then we can find the mole, and that moles will be the stoichiometric coefficient of that balanced reaction. So this way also we can balance the equation with the help of numerical. So we will understand this thing with the equation. Like suppose it is saying that we have 64 gram methanol, that is CS3OH, react with
Yeah.
96 gram of oxygen. So oxygen gas means what? Technically always oxygen, O2, right?
Okay. Right.
To produce 88 gram carbon dioxide, and 72 gram of water. We use the balanced equation for reaction.
Oh. Produce. So we need to write it down.
You need carbon, that is 12, hydrogen 1, oxygen 60. So data is provided.
And
So
the
first of all,
CA.
what you will do?
The first thing we'll do, I think, I will try to make an equation.
No, before writing equation, you have to find the number of moles, right? And
Right.
for finding the number of moles, gram is given already, mass is given. So you need molecular masses,
So we find the MR and divide it by the grams.
molecular mass of every reactant in product. First of all, our step
Okay.
one should be this, right?
So we do oxygen, which is 16 times 2. 16 times 2, which is gonna be 16 times 2 is 32. 96 divided by 32, which the first mole is gonna be 3.
Every reactant and product. That would be our step one. So what are the reactants here? First is methanol. So its MR will be 12 plus 3 plus 16 plus 1. How much you are getting?
17, 15, 15 plus 17, 50%, 32. Oxygen, I got 3. Because I divided 16, I divided 32, I divided 96 by 32.
Okay. You are finding moles directly.
Yes. But the MR is 16 times 2 basically, which
Directly
is
you are
gonna be
counting moles.
32.
Okay. So I want to write in like first you should write the molecular mass for every reactant
Yeah,
molecule.
yes,
Then
no
we will
worries, no
count.
worries.
Okay.
Yes. So it
So
is
how much
16 times
molecular
2,
mass we have for CS3OH?
32,
32.
and also 32.
Oxygen is also 32, right?
Yes,
And
correct,
for CO2 it is 44
correct.
and H2O it is 80.
8. Yeah,
Now
correct.
the step 2, find moles.
Find more. I forgot the grams.
So it is how many methanol is given 64. So 64 by 32 that is 2 moles.
Yes. The other one is 96 by 32, which is 3 moles.
3 moles, right?
And I forgot the last two, sorry.
CO2
The CO2, what's the gram of CO2? 88 divided by 44 is going to be 2.
2 and H2O 72 by 80,
It's going to be 4.
4 moles, correct?
Yes.
So now these are our stoichiometric coefficient 2, 3, 2, 4.
Yes. That's going to be the ratio, correct?
Yeah, correct ratio. So now in step 3 we can write the balanced equation. What first of all write the reactant CS3OH reacting with O2
I think H2O.
producing CO2 and water.
H2O.
Yes. Now write the moles. How many we are getting? Like 2 moles
No,
of
that was 2, 3,
yes.
and 4. No, that was 4, correct?
No, I think
4
2.
and
2
2
moles
and
of
1
CO2
oxygen.
and 4 moles of water.
And that's
Correct.
4. Yes.
Yes, correct. So this
That's
is
it.
our balanced equation. Also check once either we are doing correct or not. Something if there is something miscalculation in our process does not happen. So just cross check it after writing the balance equation. Like how many
Yes.
carbon atoms are there?
1, 2, 2,
2 carbons, 2 carbons, right? Satisfied.
correct.
Now
Yes.
check the hydrogen atoms.
3, no,
3
2,
plus
3,
1, 4.
6, correct.
So, no,
4,
8. 3
8,
and 1, 4. So 4 to the 8
and
hydrogen
4
atoms are there. Here
and
also
8.
8 hydrogen atoms, correct? Okay,
Yes.
balanced. Now the oxygen atoms.
Okay, oxygen is 1, 2, 4. No, 5, 5. Cross multiply. Cross check.
So cross check number of balanced atoms. That is our tip. That we will count like 2 carbon, 8 hydrogen, and 2 plus and 8. Right? 8 oxygens are there, I think. And 4 plus
Yeah.
4, 8 oxygen is also there. That means reaction is completely balanced. Done.
Yes. Sir,
Yes.
can we learn the types of molecules? I got confused. And
Type of molecule means?
yes, like for example, polymer, fluorine, graphene.
Yeah.
Like I
So
forgot these types. Can we just revise it a bit for the last 5 minutes?
Okay, so you want to revise that how much type of molecules or about that type?
Yes.
Okay, so which part I should revise? Let me think. Just 1 minute.
No worries.
Okay, so you have periodic table or not,
Yes.
right? And understand like oxygen, suppose. So oxygen mostly remain in the form of oxides, and metals are always form a positive ions. One
Math
thing.
is always from positive ions. Okay, yes.
So suppose like sodium Na. So Na remain in +1 oxidation state, oxygen remain in -2. So how the compound will form? We will close multiply this value. That means Na2O. This is sodium oxide. How we will write?
Okay.
Calcium oxide. So calcium have positive charge 2 and oxygen have -2. So the cross, if we are cross multiplying, technically it is
Times
2 is
1
to
times
2,
1.
Ca2O2. So we will take it a simpler ratio like calcium oxide. 2 is to 2, that is 1 is to 1 ratio. So we will write it
Yes.
calcium oxide this way, right? And
Yes.
suppose aluminium is there. So aluminium have +3, sulfate ion -2 charge. We will close multiply it. So it would be Al2 and SO4 whole thrice.
Yes.
So with the valency or charge of ion, we can write the product like this. One thing. So this is for ionic condition. Now, like you are asking for fluorine, chlorine. So these are called as diatomic molecules technically.
Okay.
So diatomic molecules are suggesting there are two atoms like hydrogen, diatomic, nitrogen, oxygen. Similarly, chlorine gas, bromine, iodine. This.
Yes.
So understand F2 is molecule as well as fluorine atom is also there. It can exist, right?
Right.
So always read the question what is given. Fluorine atom is given or fluorine gas is given. If gas is given, similarly in oxygen we did yes just before. Like oxygen gas means O2 is there. But
Correct.
if there is oxygen atom, then we will take a single oxygen atom.
Yes.
Similarly,
Okay.
for fluorine or chlorine gas, we will write F2 and Cl2 like this. And if
Okay.
it is asking for chlorine atom, then we will take a single atom.
Okay, understood.
Okay.
Yes. Thanks so much, sir.
So I think today's session was very good and entertaining as well as knowledgeful.
Yes, I liked it. Very nice.
Yeah, very good.
Sir,
So
I wish you a great day. I hope we see us on the weekend.
how the?
I hope we see us on the weekend.
Yeah, I am available.
Okay.
Okay, so
My friend.
I am sending this PDF to
Yeah.
you. You
Yes,
should
please.
revise that and then apply the homework as well, and you can do the questions. If you find,
No worries.
you can also refer your book, and if find any problem in there any doubt in your questions, right? So
Okay,
you
no
can
worries.
ask me in the next class. We will
Okay,
discuss.
no worries.
Okay,
Thank you.
so no worry. Every question you will be able to solve. Just follow the
Yes,
instructions, right?
no worries. Thanks so much, sir.
Welcome, dear. Bye.
Bye.